Welcome back, everybody. In this video, we're starting chapter 2, which is about positive and negative numbers. In this video specifically, we're going to work through the first two sections, 2.1 and 2.2. So let's go ahead and get started. As always, when we start a chapter, it's a good idea to take a look ahead and see what it is that we're getting into. So let's do that. Chapter 2 is about integers and the introduction to solving equations. So an integer basically is a number that is either positive or negative. It doesn't include things like decimals, fractions, percentages, things like that, okay? More on that in a second. So 2.1 is the kind of introductory section that talks about just what is an integer and any kind of important definitions and symbols that will be needed. Section 2.2 is about how to add integers. 2.3 is about subtracting integers. And then 2.4, multiplication and division. Addition and subtraction with positive and negative numbers is a little bit tricky, as you'll see. That's why they each get their own section. But multiplication and division is a little easier, which is why they're lumped in together. Okay. Section 2.5 is about order of operations. Again, so we did order of operations with whole numbers. Here we're going to see it again. Fortunately, it's the same set of rules you had before. It's just that now the numbers won't all be positive. We'll have some negative numbers in there. Section 2.6 has to do with solving some equations. Okay, so we'll see that when we get there. So let's go ahead and get started with section 2.1. So 2.1 is an introduction to integers. So definitions first. Numbers that are greater than 0 are positive numbers. Numbers that are less than 0 are negative numbers. 0 is neither positive nor negative. It's right on the fence between the two. So basically what happens is we take the positive numbers that you're familiar with and we extend our number line to the left. And for every positive number, there is a number called its opposite that is an equal distance away from 0, but on the other side. So for example, 3 is 3 units away from 0. And it's to the right of 0. There's also a number that is the opposite of 3, negative 3, and it is 3 units to the left of 0. So we're creating a whole new set of numbers called the negative numbers or negative integers that are occupying that space to the left of 0 on the number line. When you take those positive and negative numbers together, they make up the integers. So 0, 1, 2, 3, 4, 5, and so on, negative 1, negative 2, negative 3, and so on make up the integers. Okay, the dash in front indicates a negative. So here, this dash in front of the 3 indicates negative 3. 3 and the plus sign 3 both indicate positive 3. For a negative number, you do need to have the minus sign on it. For a positive number, it can either have or not have the plus sign, and it still represents a positive number. Okay, and as I'd mentioned before, the number 0 is neither positive nor negative. So all of these numbers together make up the integers. Little conceptual example first. Here it says the world's deepest bat colony spends each winter in a New York zinc mine, of all places, at a depth of 3,805 feet. We're to represent this position with an integer. So negative numbers are frequently used to represent things like money that is owed or heights and depths below the surface of the ocean or below ground, temperatures, things like that. Here we're going to use a negative number to represent a distance below ground. So this mine is 3,805 feet below ground, so we can represent that as its depth as negative 3,805. Okay. We can compare integers just as we compare whole numbers using less than, greater than signs. Okay. For two numbers graphed on a number line, the number to the right is the bigger number, and the number to the left is the smaller number. So we have less than, we have greater than, just as we did before. So taking a look at our graph below, negative 5 on the number line is to the left of negative 3. So negative 5 is less than negative 3. Now it looks a little awkward because you're used to saying, well, 5 is bigger than positive 3. That's true. And 3 is less than 5. But negative 5 is less than negative 3. Since negative 3 is to the right of negative 5, negative 3 is greater than negative 5. Okay, you want to remember that for greater than, the number that is greater is on the right-hand side of the number line. And for integers, where we have 0 in the middle, we have the dash for negative, and then it counts what looks like upward, 1, 2, 3, 4, 5, 6, to the left, right? So you'll have to be kind of cautious with that. Here's a couple of additional examples. Negative 10 is less than negative 8, because negative 10 would be to the left of negative 8. 4 is greater than negative 10, because 4 is bigger, 4 is to the right of negative 10. Any positive number is bigger than any negative number. Negative 6 is greater than negative 22, because negative 6 is to the right of negative 22. Okay, here are some more examples. We want to insert either less than or greater than between each pair of numbers to tell which is bigger, to make a true statement. So less than or greater than. So you may want to pause the video and try this yourself, or at least think about it as we go along. 5 is smaller than 12. Okay, negative 1 is less than 3. Any negative number is smaller than any positive number. Negative 4 is smaller than 5. Negative 6 is bigger than negative 10. Negative 10 is less than negative 4. And 3 is bigger than negative 5. Okay, make sure you can get the right answer to all of those. If you have trouble with that and are just not seeing it, you may want to pull out an actual copy of the number line and think about where each number is. Remember that the bigger number is on the right, always. Okay, numbers that are less are on the left, and on the number line, 0 is in the middle. Okay, a way to remember this is that less and left both start with the letter L. Okay, so lesser numbers are on the left. Okay, moving along. The next idea, the first section out of chapters, by the way, is often full of different definitions and symbols and new concepts. And that's true here also. We saw that in chapter 1 with the ideas of place value and rounding and all of that. It's typical that the first section has definition type stuff in it. After we're through this first section, it'll get more kind of systematic, and there will be less different new things within each section. Okay, defining the idea of the absolute value of a number. The absolute value of a number is the number's distance from 0 on the number line. The symbol for it is a pair of vertical bars. Okay, the absolute value of 2 is 2, because 2 is 2 units away from 0. The absolute value of negative 2 is also 2, because negative 2 is 2 units away from 0. Distance is always a positive number. If you think about it, if someone is 6 feet in front of you, they are 6 feet away. If someone is 4 feet behind you, they're still 4 feet away. They're just 4 feet behind you. You would never say someone is negative 4 feet in front of you, right? That just sounds silly. So distance, always a positive number. The absolute value will always be positive. Okay, that just tells us the number's distance from 0 without regard to direction, which side of 0 the number is on. Okay, so let's figure out some absolute values of different numbers. We have the absolute value of 5, that will be 5. How far is negative 4 from 0? Negative 4 is 4 units away from 0. It happens to be on the left, but who cares? Okay, it's 4 units away and that's it. Okay, how far is 0 from 0? Well, it is at 0, so the distance is 0. Okay, absolute value of negative 7 will be positive 7. Absolute value of 25 will be 25. Okay, so a way to think about absolute value is that, well, if you're taking the absolute value of a positive number, the answer is just that number itself. If you're taking the absolute value of a negative number, you will give back the opposite for an answer. Okay. Speaking of opposites, more on opposites. I'd mentioned this before, but we go into that in more detail here. Two numbers that are the same distance from 0 on the number line, but are on opposite sides of 0 are called opposites. So 5 and negative 5 are opposites because they're both 5 units from 0. One's on the right, one's on the left. Okay, similarly, 7 and negative 7 are opposites. Negative 6 and 6 are opposites. In the first case, 7 and negative 7 are both 7 units from 0. 6 and negative 6 are both 6 units from 0. We're going to have to be careful going forward because the dash here represents two things now. It represents subtraction, the difference between two numbers, and it also represents the opposite of a number. A quick way to tell the difference in the two meanings is that for subtraction, it's going to be between two things, right? 10 minus 4. The dash is in between two things. And that means 6. It's a subtraction. If you have negative 125, here the negative 125 is not in between two things, okay? It's just in front of the 125, so that means a negative value. Okay, 5 is the opposite of negative 5, and negative 5 is the opposite of 5. Okay, the opposite of 4 is negative 4 and is written in the following way. The dash in front of 4 is going to give us the opposite of 4, or negative 4. The opposite of negative 4, so you want to be careful with this one. The opposite of negative 4 will be positive 4. Sometimes people will look at that and say, okay, two negatives make a plus. You want to be careful with sayings like that because sometimes they can be misinterpreted. The opposite of the negative number will be positive. The opposite of 4 is just going to be 4. Okay, in symbols, if A, representing any number, if A is any number, then the opposite of A is just going to be A. We're almost done with the section anyhow. Okay. So remember that 0 is neither positive nor negative, and so that means that the opposite of 0 is going to be 0. There is no different opposite for 0. Okay, otherwise, let's find the opposite for these 7 numbers. So the opposite of 7 will be negative 7. The opposite of negative 5 is 5. The opposite of 13 is negative 13. The opposite of 0 is just 0. The opposite of 105 is negative 105. The opposite of negative 16 will be positive 16. The opposite of negative 31 will be 31. Okay, so just examples of finding opposites. As a reminder, the dash is used for both subtraction and finding opposites. We're going to connect those later on in this section. Okay, a couple more examples. In these, we want to simplify some expressions. The opposite of negative 5 is going to be positive 5. Here, inside the absolute value bars, notice that there's a difference between this one and the prior example, aside from the fact that one was a 5 and one's a 6. One is parentheses, the other one's an absolute value bar. Working from the inside out, the absolute value of negative 6 is going to be a 6. And so we have the opposite of 6, which is negative 6. Okay, so this can be confusing, so let me do this kind of in 2 steps. The opposite of negative 6, or the absolute value of negative 6, will be positive 6. So the part inside the vertical bars is going to give us a 6. And then we had the opposite of symbol in front. So our final answer there is negative 6. Okay, and now we have the absolute value of 7, which is 7, and then put a dash in front, so negative 7. Okay, if you're confused, if you're thinking, I thought you said that absolute value has to always be positive. Well, it's true, the absolute value portion is positive, but this has a dash in front, making it negative. Okay, so we end up with negative 7 for our final answer. Okay, last example for this section, we're going to evaluate an expression. Remember that evaluate, the kind of key part of that is VALU, which is 80% of the word value, right? So we're finding the value of something. And so we want to evaluate the opposite of the absolute value of x for x equaling negative 6. And so what that means for us to do is take the expression and replace the x with whatever x is equal to. In this case, it is negative 6. So our intermediate result is the opposite of the absolute value of -6. I've replaced the letter with its value, which was -6. Absolute value of -6 is just going to be a 6, and then the dash in front is going to come straight down. And so we'll have a final answer of just -6 for this. All right, that takes us to the end of section 2.1. In the next part, we're going to go on to section 2.2, which is about adding integers. Okay. All right, so what we're going to work on next is doing addition with integers. So how to get this done. So there's several ways of visualizing the addition using integers. You can use a number line, you can use counters, and other means. Analogies involving money sometimes are helpful too. So we're going to first look at how you can represent these using an arrow or arrows. There's no one right way to do this. Sometimes people find one way of thinking of it easier than another. So whatever works for you works for me. I like to show different ways so that because different people have different preferences. Okay, so here we're going to take -2 and add -3 to it. So to add this using a number line, we're going to start at 0, and then let me put on -2, which would be 2 jumps to the left, and that would put us at -2. Let me add on to that 1, 2, 3 more jumps in the negative direction. And so that leaves us at -5. So -2 plus -3 would equal -5. And that's how that goes. Here's one where the one add end is positive and one add end is negative. So let me do that one. So we're going to start with -8. So I don't feel like putting on all the tick marks. I don't really have to for this. So starting at -8, I want to add to it +3. So positive is moving in the right hand direction. So we're going to move 1, 2, 3 steps in the positive direction, and that would put us at -5 for a final answer. Okay. My preference is actually not using arrow diagrams, as you can probably tell. If you like using arrows, go ahead. I think it's easier actually to have other methods. So I'm going to show you those next. Okay. How to calculate the sums really depends on whether the add-ins have the same or different signs. So we're going to do this kind of in 2 phases. We're going to take care of the situation where the add-ins, that is the numbers you're adding, have the same sign, okay? So if 2 numbers have the same sign, what do you do? 2 steps, pretty straightforward. Add their absolute values together. That is, as if they're both positive, add them up, and then use their common sign. By common, they mean shared. That is what in common, maybe they should say in common sign, the shared sign they have. Okay, use their common sign as the sign of the sum. So as an example, -7 plus -5, the absolute value of -7 is 7. And the absolute value of -5 is 5. 7 plus 5 is 12. That's step 1. Then use their common sign as the sign of the sum. -7 plus -5, we're adding together 2 negative numbers. We get a negative answer. Okay, 14 plus 10, their absolute values are 14 and 10. 14 plus 10 is 24. And we're adding together 2 positive numbers, so we should get a positive answer. Okay, when you're adding together 2 numbers that have the same sign, I think that's probably the most straightforward case. Of course, if you're adding together 2 positive numbers, there you're just working with whole numbers, which we've already practiced. When you're adding together 2 negative numbers, you want to think about it as giving you a negative sum. We're used to addition as making things bigger. Like if I added some points to your test, right? You'd think, okay, well, that would help you, right? Makes it bigger. But when you're adding a negative number, it actually makes it smaller. So thinking perhaps in terms of money, that may help you. If somebody had written a check for $7 and also a check for $5, what would be the change in their account balance? Well, a check of $7 and a check of $5 put together, that is added, would decrease their account by $12. Okay, if somebody lost 7 pounds in 1 month and then they lost another 5 pounds in another month, then their accumulated, that is added, decrease in weight would be 12 pounds over those 2 months. Okay, I'll leave it to you to make up your own story involving I don't know, a gopher digging 7 inches underground, and then another 5 inches underground, and then how far down is he after all? Okay, all right. So if you're adding together two numbers with the same sign, add their absolute values, and then the sign of the sum is the sign of the numbers you're working with. Okay, and that's kind of summarized here as well. Use the putting together idea of addition along with something real like money or weight or distance underground. Your answer should make sense. Okay, suppose that you work 18 hours this week and 14 hours next week. How many hours is that in all? Well, it should be pretty clear that if we have 18 hours one week and 14 hours the next week, that's 32 hours. Right? We're just adding together two positive numbers. Okay, Bob loses 3 pounds this month and 2 pounds next month. How much is that in all? Well, we can represent the first loss with a -3. The second loss is a decrease of 2 pounds. So -3 pounds plus -2 pounds is a total loss of 5 pounds. Okay, so we lost 5 pounds altogether. Okay, a couple more examples. Suppose that you have -$12 in the bank. Unfortunately, if you write a check for $25, that's going to be another decrease to your account. What will be your new balance? So right now you have -12. We're going to add to it another decrease of 25. You will be in the hole that is overdrawn by $37. Okay. More examples. Pause the video, try these, and then restart it and see how you did. All right, so 12 plus 17, that's going to be 29. We're adding together two positive numbers, we get a positive answer. -3 plus -18, we're adding together two negative numbers, so we'll get a negative answer. And then 18 plus 3 is 21, so -21. Okay, 8 plus 11, 19. Okay, -43 plus -12, again, we're adding together two negative numbers, we'll get a negative answer. 43 plus 12 is 55. Okay, if you don't get those or not seeing it, let me know and we can go over it. Okay, if the two add-ins have different signs, this people usually find tricky. So if that's you, you want to pay extra special attention to it until it becomes more natural to you. Okay, but let's go through the specifics. So if you're adding together two numbers that have different signs, you find the larger absolute value minus the smaller absolute value. So you take the two numbers you're adding, you find their absolute values. Subtract the bigger minus the smaller. That's step one. Then step two, use the sign of the number with the larger absolute value as the sign of the sum. Let's try it out. -11 plus 18. Okay, the absolute value of -11 is 11. The absolute value of 18 is 18. Okay, there's the two absolute values. Find the step one. Find the larger absolute value minus the smaller one. So 18 minus 11 is 7. Step two. Use the sign of the number with the larger absolute value as the sign of the sum. So between -11 and 18, which had the bigger absolute value? Well, 18 does, okay? And it's positive, so our final answer will be a positive 7. I'm going to put a plus sign on there just for emphasis. Okay, 8 plus -13. Okay, the absolute value of 8 is 8. The absolute value of -13 is 13. Subtract those two absolute values. 13 minus 8 is 5. Okay, and then I'm adding together two numbers, different signs. The one with the bigger absolute value is the -13, right? Which is negative, and so our final answer will be negative. So we get -5 for that. Okay, if you like a way to think about this with the arrows, let's try that. So if you are at -11, okay, on the number line, and you added 18 to it. Okay, adding a positive number would move us in the positive direction. So if you were to add 18 to it, that would move you in the positive direction. The first 11 would bring you to 0, right? And then the additional 7 would put you to positive 7. Okay, so the final answer there is 7. Okay, for the 8 and 13, let's say that you are at positive 8. If you were to add on to it negative 13, that means we're moving to the negative direction by 13 units. And so 8 of them will take you to 0, and then the rest of it, the remaining 5 will put you at negative 5. Okay. All right, a couple more examples. Okay, negative 21 plus 12. Okay, the absolute value of negative 21 is going to be 21. The absolute value of 12 is 12. 21 minus 12 is 9. Then we're adding together two numbers. One's positive, one's negative. The one with the bigger absolute value is the negative one. So our final answer would be negative. Okay, 22 plus negative 9. To get this done, we're going to subtract the absolute values. The absolute value of 22 is 22, and then the absolute value of 9 is 9. 22 minus 9 is going to be 13. Here we're adding together two numbers. The one with the bigger absolute value is the positive one, so we have a positive final answer. Okay, negative 25 plus 25. For this one, we're adding together a number and its opposite. So I know that we're just going to end up with 0 for that. Okay, one important point, since addition is commutative, right? 5 plus 2 is the same as 2 plus 5. Since addition is commutative, it doesn't matter if the first or second is negative. Okay, so if you look at this and say, okay, well, the negative 21 is the first number and 12 is the second. Would this be different than 12 plus negative 21? It doesn't matter what order it's in, right? So don't be thinking, okay, well, the first is negative and the second is positive. Okay, it doesn't matter which is in front. Okay, it doesn't matter if the first or second is negative. All that matters is if the signs are the same or different. If the signs are the same, here the graphic can help you down here to the right. If you're adding together two positive numbers, you get a number that is more positive. If you're adding together two negative numbers, you get a number that is more negative. Okay, if the signs are the same, that's what you get. If you're adding together numbers where the signs are different, like a big positive and a small negative, here the size of the oval is representing the absolute value in a way. A bigger, in a sense, positive number plus a small negative number will give you a smaller but positive number. A small positive number plus a big negative number will give you a smaller negative number. Okay, so let's try some examples. 20 or 17 plus 3, I gave it away, sorry. 17 plus 3 is 20. Okay, same sign, both positive. That was chapter 1, nice and easy. Okay, negative 20 plus 8. Here we're adding together the two numbers. The signs are different, and so we will subtract their absolute values. So negative 20 plus 8, that is going to be 20 minus 8, which is 12. And there we're adding together two numbers that are different in sign. The one with the bigger absolute value is the negative one, so we would have negative 12. Okay, negative 12 plus negative 4, we're adding together two negative numbers. Get a negative 16 for an answer. Okay, 15 plus negative 3 will be positive 12. 11 plus 14 is 25. Negative 11 plus negative 14 will be negative 25. Negative 17 plus 3. Okay, so you want to be very careful. Is it negative 20? Is it negative 14? Is it 14, negative 20? What is it? So here we're going to add two numbers that have different signs. So we're going to subtract their absolute values. Okay, so 17 minus 3 is 14. The one with the bigger absolute value is the negative one, negative 14. 17 plus negative 3 We're adding together two numbers that differ in sign, so we'll again subtract their absolute values. This time, the one with the bigger absolute value is the positive one, so positive 14. Okay, one of the difficulties that people have with this is they get confused. Why is it that when we're adding, I thought we were adding, why is it that when we're adding, we end up subtracting numbers? Okay, why do we turn it into a subtraction problem? So I wanted to address that next. All right, so to try to resolve that, why is it that we do subtraction, it looks like, when we're trying to do an addition problem? So to do that, we're going to use another way of representing this addition of positive and negative numbers, and that's using counters. Some people call them counters or chips or tokens, but it doesn't matter what you call them. What we want to do is, instead of representing a positive 1, with the number 1, we're just going to use the plus sign for this. Some people draw these with circles of different colors, however you like. Okay, a negative 1, we're going to represent that with just the minus sign. And so, like I said, you can use chips of different colors or single plus signs and minus signs. So an important fact with this, if you're going to do this, is that 1 plus negative 1 is going to equal 0. And that should be, I'm hoping, kind of an intuitive fact. If you gained a pound and then lost a pound, your net change is going to be 0, right? Your net increase in weight is going to be 0. If you found $1 on the ground, you put it in your pocket, and then it fell out the hole in your pocket, then you're back to where you started, right? If you take one step forward and then one step backward, you're again back to where you've started. An addition of 1 followed by an addition of negative 1, an increase of 1, and then a decrease of 1 together should leave you where you started, that is at 0. Okay, so we're going to take that to be kind of a fundamental fact. So a plus and a minus together are going to equal 0. Okay, plus and minus together are going to equal 0. Okay, so with that in mind, let's see if we can represent some addition problems in this way. Starting off easy, I know you know how to do this already, but we got to start somewhere. 5 plus 2 would be 5 plus signs. That's plus 5, plus another 2 plus signs. Altogether, how many plus signs is that? Okay, I'm sure you thought 7, and you're right. Okay, negative 5 plus negative 2, that would be negative 1, 2, 3, 4, 5 negative signs, and then 2 more negative signs. In all, how many negative signs is it? There are negative 7 of those negative signs, so negative 7. Okay, negative 5 plus positive 2. So this would be negative 1, 2, 3, 4, 5, and 2 positives. Okay, remembering our important fact that a negative and a positive together equals 0, I know that these two are going to equal 0. Okay, a negative and a plus are going to equal 0. What's left over is 3 minus signs, which is why our final answer is going to be negative 3. Okay, 5 plus negative 2, there's 1, 2, 3, 4, 5 pluses and 2 minuses. Okay, as in the last example, these plus minus pairs are going to equal 0. A negative 1 plus 1 equals 0. This time, what's left over is going to be positive 3. Okay, so hopefully that makes sense so far. So we still have not addressed why the subtraction part. So let me do one more in this same basic way. Let's say that we had 50 and negative 17. Okay, so I know you don't want to see me draw 50 plus signs, right? And then 17 minus signs, and then you'll just fast forward over all that anyways, right? So, but let's just pretend that I did, okay? If we had added 50 and negative 17, if I actually did write out those 50 plus signs and 17 minus signs, then we'd end up with more of which one? Well, we're going to circle those pairs as we did before. We're going to circle 17 minus signs and 17 plus signs. So then what's left? Which one is there more of? There's more plus signs, and how many more? There are 33 of those extra plus signs. Okay, the reason why you end up subtracting, why would you go, okay, 50 minus 17, getting 33? Why are you subtracting? Because of comparison. We're comparing the 50 plus signs against the 17 minus signs. And as you recall, one of the three meanings for subtraction is to compare two numbers. We're comparing 50 plus signs against 17 minus signs, and we want to see how many more plus signs there are. So subtraction is how we do comparison. We want to see how many more of those there are. Okay, one more example. Negative 21 plus 5. Okay, again, if we drew out all those minus signs, there's 21 minus signs and then 5 plus signs. Okay, there's going to be more minus signs. How many more? Well, in order to figure that out, we need to compare via subtraction. So that would be 21 minus 5. That's 16. And it is extra negative signs that we have. So the final answer there is negative 16. Okay, so then hopefully that makes some sense. Again, this boils down to not which number is in front or back. What matters is which or how many positive and how many negative add-ins you have. Okay, a couple more examples and then we'll be finished. So for this, we want to add 5 plus negative 7, and then we're going to add 3. So 5 plus negative 7, they were adding together two numbers that are different signs. So we're going to subtract their absolute values. That's 2. And then 5 plus negative 7, there's more negatives than there are positives. So that's negative 2. Plus that 3 I had all along. Negative 2 plus 3 is just going to be 1. Okay. An evaluate question. 3x plus y when x is 2 and y is negative 8. Our first step would be to replace the x and y with what they are. So remember that the x has to be replaced by the x value and the y is replaced by the y value. Okay, 3 times 2 is 6, and then negative 8 in the back. Finally, down to the addition. 6 plus negative 8 will be negative 2. Okay, a little story problem. The temperature at 4 p.m. on February 2nd was negative 10 degrees Celsius. By 11 p.m., the temperature had risen, so gone up, sounds like a plus, 12 degrees. We want to find the temperature at 11 p.m. So it was negative 10 degrees Celsius in the first place. It rose up by 12 degrees. So now it's going to be 2 degrees Celsius at the end. All right, so that takes us to the end of our work with addition of signed numbers, of positive and negative numbers. Remember the pattern and make sure to do lots of examples. I've put in the notes here another whole set of examples. These are taken from a book. You can work through those. I'll do a few of these and put them in the notes as well. Also on the next page, there are some with some more add-ins in them. So try some of these, try the assignments. Let me know if you have any questions, and then have a great afternoon.